Welcome back to Computer Science and Engineering 120 Learning to Code. This is Module 13, Organizing Code Part 2, Project Organization. In this module, we look in detail about the issues involved when using libraries and other frameworks. We'll also look at project organization and best practices. Finally, we'll talk about collaboration and version control using Git. Software development is not done in a vacuum. That is, you're not on an island by yourself writing your own code all the time. Developers frequently make use of libraries, plugins, frameworks, and other things to avoid reinventing the wheel. This provides for much faster, much quicker development time. Some examples of things that we've used throughout the semester: jQuery and jQuery UI, along with our hundreds or thousands of plugins and libraries associated with them. We've also used Bootstrap, which provides a framework for basic styling. There's also HTML5 boilerplate, which provides some basic functionality for HTML5. There are also other libraries that can be used, such as Modernizer and Initializer, to bring some of these libraries together into one. Larger than libraries, frameworks provide many more features for a fuller application. Whereas a library provides functionality that you can choose to use in your own application, a framework provides inversion of control. That is, the framework provides the basic control and you provide specialization. Using a framework means that there's far less programming and far more configuration. There is less work, but customization becomes more difficult because you have to use the functionality that the framework provides. Many of these frameworks provide what's called an MVC model. That's a model view controller model, in which there is a separation of responsibility. The model keeps track of the data model. The view is what is generally seen by the user, and the controller acts as a go-between, handling all the basic business logic. Some of these frameworks also provide an SPA functionality, that is, a single-page application, where you have the full functionality of a desktop application but run it in a browser so that it can run on multiple systems. Let's take a look at the following website, which provides a showcase of some of these frameworks. ToDoMVC.com provides examples of the same to-do application written in several different frameworks, including Backbone, Knockout, Angular, and many others. If you take a look at the code, the showcase is intended to let you see how each one of these frameworks achieves the following application, where you can write down things in a to-do manner. As you can see, there are many of these types of frameworks out there. Not all of them are ready for prime time, and many of them are still under development. There are also some legal issues when you use a framework or a library. Some people or institutions write software to make money and release it under a license that requires you to pay for it. Some software is free as in beer, where you can use it for free as in no monetary cost, but you're still subject to the copyright holder wishes. Still others develop free and open source software, or FOSS for short. FOSS is free as in freedom, free of any copyright claims by the developer. You cannot simply use a piece of software, framework, or library as you want. Understanding licenses and what you can do under those licenses is absolutely essential. Here are some examples of licenses. The MIT license is an unrestricted license. It allows you, the user, to use the software for whatever purposes you want. jQuery, jQuery UI, and Bootstrap are all released under the MIT license. Furthermore, it indemnifies the issuer from liability. For example, if you use jQuery in a project, and a bug in jQuery causes your project to suffer a monetary loss, you cannot then go and sue the makers of jQuery. You essentially gave up that right by using the library because of the MIT license. GPL, the GNU General Public License, is another more complex and complete legal license. It may require the continuation of the license to any derived products. For example, if you use a GPL piece of software in your software, then you may need to release your software under the GPL as well, limiting your ability to perhaps charge people for it. The Apache license is less restrictive, and it allows the issuer various permission to restrict the rights of derived works. Creative Commons is another open licensing scheme that allows you to share and share alike. In other words, if you release something under a Creative Commons share and share alike, like this course is, then other people are free to use the materials. However, they must share the materials as well. They cannot then make the materials proprietary. You can also specify that they must give attribution to the original source. Another thing to understand in software development when using a library is versioning. Typically, when a new version of a library comes out, a new version number is associated with it. Your code may be written to a particular version. An older version may not support the features that you want to use, or it may contain unpatched bugs or inefficiencies that then negatively affect your project. New versions may deprecate or no longer support older features. Semantic versioning communicates the differences between these versions, giving you an idea of what applies. Typically, it has three numbers: a major, a minor, and a patch number. For example, version 2.1.4. The major number indicates a non-compatible major new release. It may break backwards compatibility, and upgrading may require you to make changes in your code. A minor version release may add or improve features, but generally they are backwards compatible. A patch indicates bug fixes and other improvements that do not necessarily introduce new changes, such as minor or major. Another important aspect to a good project is keeping everything organized. Complex projects and applications may have many assets: images, style files, source files, HTML files, data files, etc. As a project becomes more complex, organization becomes extremely important. It's good to separate out different assets into separate folders. For example, keeping libraries in version stamped folders. Let's take a look at an example. Here we have a project in Lighttable. It has an assets folder. Within that assets folder, we've separated out CSS files, image files, JavaScript files, and our library files. Library files are separated out into one for each library, with version stamped directory names. Throughout the semester, when we wanted to use a library, we've been hot linking, or that is inline linking, to bring in several assets from content delivery networks, so that we didn't have to have our own local copy. One advantage to this is that you don't waste your own bandwidth when serving users with these assets, and it may be faster. There are some distinct disadvantages, however. A CDN may become unavailable, meaning that your application is broken even though all the other files and your server is up and running. A CDN may change the terms of service. They could block or cease service altogether, crippling your application. A CDN may inject their own code for their own benefit, advertising or tracking services. There are also security risks. If the CDN becomes compromised, then so is your application. The solution is to serve your assets from your own project by using local copies, as we just saw in the example. We download the libraries and place them in local folders. Then, instead of hot linking, we make a reference to the local folder versions. Another tool to improve a project are minifiers and transpilers. In general, code formatting, indentation, and style is so that humans can easily read your code. But computers don't care about readability, only syntax. JavaScript minifiers allow you to make source code more compact by removing whitespace, shortening variable names, and other optimizations. This could lead to smaller JavaScript files that are quicker to transmit over a network. Let's take a look at a demonstration using Google's Closure minifier. Here I'll cut and paste some code from our album application that we made a while ago. As you can see, the resulting JavaScript is much more compact. The original size was 2.87 kilobytes. The compiled size is 1.77 kilobytes, meaning that we saved about 38% from the original, almost half of what it was. You can imagine if we were serving thousands of users, this would be a huge improvement. There are many other tools, for example, linters. A linter is a code analyzer that can call attention to some common errors, bugs, or suspicious-looking code that is likely to cause problems. A linter doesn't necessarily find syntax errors. Instead, it finds patterns that may need to be addressed. A transpiler is another tool that can translate from one high-level programming language to another high-level programming language. For example, suppose that we want to write our application using ECMA script version 6. But we want to support ECMA script version 5. For compatibility, we could transpile ES6 code into ES5 code so that nearly every browser will be able to support it. Another example is that you can translate a high-level language like Java into JavaScript so that it can be run in the browser. Something that's currently being developed is ASM. Also known as WebAssembly, where you can pretty much write in any high-level programming language, which can then be compiled down into low-level WebAssembly language, which is a subset of JavaScript. These technologies are still being developed. Large, complex projects typically require multiple developers. Developers need a way to be able to work independently on the code base, but still be able to collaborate to make changes and share those changes with each other. We also need to be able to keep track of versions, legacy code, and other artifacts. The solution is to use what's called a version control system. A version control system is a repository of files, including source files, data files, and other assets that you may want to check in. Users can check out copies and work independently on them. Once they've made changes, they can check those changes in. Every change is tracked. SVN, or subversion control, is such a system that allows you to do this. SVN, however, is centralized. The repository of code and assets is stored on one server. Everybody has an independent copy of it, but the history of the project is stored on that one repository. Other examples such as Mercurial and Git are decentralized version control systems, where each repository copy has a full version history. Typically, users clone copies of the repository. Then they can commit changes to their cloned copy. Users can either push changes to a remotely stored repository, or they can pull changes to their repository. GitHub is a very popular, though closed, Git repository host. Users can freely use GitHub for public repositories. If you pay for a subscription, you can also have some private repositories. There are more open alternatives, such as GitLab or Bitbucket. Let's briefly take a look at GitHub. Here's my GitHub profile. Every repository on my profile is public, meaning that you can clone everything. All the code that we've been using throughout the semester has been hosted on GitHub. GitHub has a user interface that allows you to browse files and take a look at changes. You can clone the project by downloading it, which is what we've been doing pretty much throughout the semester, or fork it off into your own version so that it can eventually be merged back into the main project as you work on it. You'll get some direct experience in the activities this week of using GitHub.